everyone, welcome to Sangam Tutorials, SP Gubi online classes for NCERT and Cbse 10th standard for mathematics and science. So in the previous session we had discussed regarding the Pythagoras theorem and we proved it logically on the basis of similar triangles. So and also we have worked out some conceptual problems and a simple rider on Pythagoras theorem. So in today's class we will be going with the converse of Pythagoras theorem, very important. No proof for this will be asked in your examination. Just you have to understand and remember the statement. The statement will be asked for 1 mark. State converse of Pythagoras theorem. So this is the question which will be asked in your examination. Very simple, right? So now, before getting into the converse of Pythagoras theorem, let us recall Pythagoras theorem. So therefore we can easily understand its converse. So this is triangle ABC with angle B is equal to 90 degrees. So let us take triangle ABC where angle B is equal to 90 degrees. So in triangle ABC, if angle B is equal to 90 degrees, then AC square is equal to AB square plus BC square. So this is Pythagoras theorem. You have to remember this. So in any triangle, if angle B is equal to 90 degrees, in the sense if one of the three angles is equal to 90 degrees, then the square which is built upon the side opposite to the right angle, that is, if you build a square on the side opposite to the right angle, then the square's area will be equal to sum of the squares which is built on the other two sides. So this is AC square is equal to AB square plus BC square. This happens only in this triangle if one of the angle is 90 degrees. So in a right angle triangle, right, if B is equal to 90 degrees, that is in a triangle if one angle is 90 degrees, then we say that AC square is equal to AB square plus BC square. Sum of these two squares will be equal to the area of the square which is built on the hypotenuse, right? So this is right angle triangle. If angle B is 90 degrees, that is, if the triangle is right angle, then AC square is equal to AB square plus BC square. Remember this? This will become easy now, right? So according to the converse of Pythagoras theorem, usually what we do is, in the Pythagoras theorem statement we have two parts in it. One is the hypothesis, the first part of the statement, and second part of the statement is conclusion. So in the converse of Pythagoras theorem, just we reverse that. So we do the hypothesis part of the statement as conclusion and conclusion part of the statement as hypothesis. So here in Pythagoras theorem, in right angle triangle ABC, according to the statement, I hope you remember, in a right angled triangle means one of the angle is equal to 90 degrees. So that is what I have written here. If angle B is equal to 90 degrees, this becomes the hypothesis and this becomes conclusion. So here we are making this conclusion part as the hypothesis in the converse of Pythagoras theorem, and we will make this as the conclusion, right? So how it goes, it's very simple. So imagine a triangle. I am not going to mention that it is a right angle triangle. I don't know whether it is what type of triangle, I don't know that. So it is just a triangle, and I just know that this is the longest side. If you take it as ABC, so AC will be the longest side. AC will be the longest side. So if I build a square on the longest side of this triangle, so I have a triangle, I don't know, or I will never mention that the triangle is a right angle triangle. Just I have a triangle and I have identified one of the sides as the longest one. So AC will be the longest side. So I am going to build a square on this longest side of the triangle, and I will build a square on the other two sides, right? So I come to know that the area of this square is equal to the sum of the areas of these two squares. That is, AC square has become equal to AB square plus BC square. That is, the square on the longest side of this triangle is equal to the sum of the squares on the other two sides. That is, sum of the squares on the other two sides. This has happened. So in triangle ABC, triangle ABC, if AC square is equal to AB square plus BC square, that has happened there. So if this is the thing happened, then apart from the longest side of the triangle, the two sides which are called the remaining sides, they will contain the right angle. That is, they will be having the right angle between them. So this is the converse of Pythagoras theorem. So that is how it goes. If the square on one side of a triangle, or we can take this as one side as the longest side, no problem. So if the square on one side of a triangle is equal to sum of the squares on other two sides, this is the longest side of this triangle. So on the longest side I have built a square. The square on the longest side of the triangle is equal to sum of the squares on the other two sides. That is what I have written mathematically here. So if this is true for a triangle, this is what happening in the triangle is true, then those two sides contain the right angle. Those two sides means apart from the longest side of the triangle, these are the two sides, and these two sides contain the right angle. That is, angle B is equal to 90 degrees. So you can please check out here. So this is the hypothesis part of the statement, and this is the conclusion part of the statement here. So here in the Pythagoras theorem, this is the hypothesis part and this becomes the conclusion part. You can see here just they have interchanged. So hypothesis has become conclusion here, and the conclusion has been here as the hypothesis. So this is the converse of Pythagoras theorem. So you have to by heart this. In the sense you have to remember well, and you should be able to recall whenever it is required. So if the square on one side of a triangle is equal to sum of the squares on the other two sides of the triangle, then those two sides contain the right angle. So this is the converse of Pythagoras theorem, which is very important. We are going to apply this in very important numericals as well as some writers. So once again, if the square on one side of a triangle, one side can also be taken as the longest side. If the square on the longest side of a triangle is equal to sum of the squares on other two sides. This is the longest side. I have built a square on the longest side here. So the area of this square is equal to sum of the areas of these two squares. So therefore, if this is true, then those two sides contain the right angle. So there is no proof for this. In the sense, we have the proof for this, but it will be not actually asked in your examination. Just you have to remember the statement, right? So I have to remember this and recall this whenever required. Right. So we'll get into very simple problems today. Okay. In triangle ABC, very important, right angled at C, right angled at C, let BC is equal to A, which the side BC is represented by small letter A, CA is equal to B, and AB is equal to C, CD is equal to P, and CD perpendicular to AB, and CD perpendicular to AB. Then prove that. Very simple. First one, CP is equal to AB, and second one, 1 by P square is equal to 1 by A square plus 1 by B square. This is what we have to prove. So let us go with the diagram. Diagram is given. So this is the right angle triangle. This is right angle triangle, right angled at C. So this is 90 degrees, right angled at C. Okay. Now, in triangle ABC, right angle at C, let BC is equal to A. BC is represented by small letter A. In future, instead of BC, we will be using A. CA is equal to B, that is CA is equal to small letter B. So instead of AC, we will be using B. And AB is equal to C, this entire AB will be equal to C here. So instead of AB, for calculations, we will be using C. And CD is equal to P. CD is drawn perpendicular to AB as mentioned. So CD is equal to P, right, small letter P. CD perpendicular to AB, it is mentioned here. So prove that CP is equal to AB, that is C, that is AB, C, P is equal to, that is C into P is equal to A into B. So we will prove that first and then we will look into the second one. 1 by P square is equal to 1 by A square plus 1 by B square, right. So let us get into the solution. So here, so there are two right angles here. One is angle ACB, another is CDB, another is CDA. Okay, three right angles we have here. So we have to prove that first. In the first question, we have to prove that CP is equal to AB. So very simple. So now in triangle ACB, we'll take this in triangle ACB. Angle C is equal to 90 degrees. So therefore we will take the area of this, area of triangle ACB is equal to, so for triangle ACB, BC becomes the base and AC becomes the height. So half into base into height. So that is half into BC into AC. So that is half into BC is represented by A into AC is represented by B. So we will put on this. So that becomes half AB. Take it as equation 1 here. So again we will take the area of the same triangle. So area of triangle ACB is equal to, so now this becomes the base for triangle ACB. This becomes the base. That is, if you consider this AB as the base and CD as the height, then again we can find out the area of triangle. So area of triangle ACB is equal to half into, take AB as the base and CD as the height. So AB into CD. So that becomes half into AB. AB is represented by small letter C into CD is represented by small letter P. So half into C into P, so that becomes half CP. Take it as equation 2. So now half AB is equal to area of triangle ACB and half CP is also equal to the area of triangle ACB. So therefore we can equate them. So from equations 1 and 2, half AB is equal to half CP. So therefore half and half cancels. So therefore CP is equal to AB. So this is the first answer we have got. We have proved that, right? So now we go with the next one. So 1 by P square is equal to 1 by A square plus 1 by B square. We have to prove that. So we will take this result and continue. So CP is equal to AB. So now P, make P as the subject. So P is equal to AB by C. Take squaring on both sides. We will do squaring on both sides. That becomes P square is equal to AB by C whole square. So that becomes B square is equal to A square B square by C square, because the square applies for all the three elements. So we will take reciprocal. So 1 by P square, we will take reciprocal on both sides, because below P square in the denominator we have 1. So that when we take reciprocal, it becomes 1 by P square is equal to C square by A square B square. So now the turning point. So 1 by P square is equal to, instead of this C square, what we can do is, if we apply Pythagoras theorem to triangle ACB, that is with angle C is equal to 90 degrees, opposite to this is hypotenuse, that is AB, which is represented by C. So therefore, when we apply Pythagoras theorem to this, C square, that is AB square is equal to AC square plus BC square. If you apply for the symbols which are given, so C square is equal to B square plus A square, or C square is equal to A square plus B square. So instead of this c square, we can write a square plus b square by, again we'll repeat this, a square b square. So 1 by p square is equal to, so you can split this a square by a square b square plus b square by a square b square. So where a square and a square cancels, b square and b square cancels, so remaining thing is 1 by p square is equal to 1 by b square plus 1 by a square. So this can be altered by using commutative property for addition. So 1 by p square is equal to 1 by a square plus 1 by b square. So this is the second result, hence it is proved. So this was asked in one of the examination for Karnataka state syllabus from very few years ago. It's a very peculiar problem, very nice, where we apply Pythagoras theorem in a very simple manner, which is at this step, at this particular step, by using Pythagoras theorem, right? So this is how it goes, very important. Okay, we'll go with the next problem. ABC is an isosceles triangle . ABC is an isosceles triangle, right angled at C. Right angled at C. Prove that AB square is equal to 2AC square. AB square is equal to 2AC square. So very simple problem. So ABC is an isosceles triangle, right angled at C. So this will be the diagram. So this is the right angled triangle, which is right angled at C. So ABC is an isosceles triangle, right angled at C. So therefore hypotenuse, so we cannot touch that. So therefore BC will be equal to AC, because if two sides of a right angled triangle are equal, then it is called an isosceles right angled triangle. So if these two sides are not equal to each other, then it is just a normal right angled triangle. If two sides are equal, then it is called as an isosceles right angled triangle. So here we have to prove that AB square is equal to 2AC square. Okay. So in triangle ABC, angle C is equal to 90 degrees, and along with that AC is equal to BC. AC is equal to BC, because it is given that it is an isosceles right angled triangle. So by applying Pythagoras theorem, so we get the result. So that is opposite to the right angle is the hypotenuse, that is AB square is equal to AC square plus BC square. So AB square will keep it like that. So here AC is equal to BC. So therefore instead of BC we will write AC again, because we have to prove that it is 2AC square. So we will write this AC square as it is. Instead of this BC we will write AC once again. So AB square is equal to 1AC square plus 1AC square is 2AC square. So it is such a simple problem. So hence it is proved. Okay. ABC is an isosceles triangle. ABC is an isosceles triangle with AC is equal to BC. With AC is equal to BC if AB square is equal to 2AC square, prove that it is a right angled triangle. Prove that it is a right angled triangle. Okay. So in a question, if you are asked to prove that the given triangle is a right angle triangle, something like that, so it's nothing but a problem on converse of Pythagoras theorem, right? So we'll go with the solution. ABC is an isosceles triangle, so which is right angle, which is with AC is equal to BC. So ABC is a right angle triangle. ABC is an isosceles triangle with AC is equal to BC. So this BC has become equal to AC, right? If AB square is equal to 2AC square, it's already given in the previous problem. Just now we have proved this. So we'll go reverse in the reverse order of that. That's all. Previous problem is done in the reverse order. So AB square is equal to 2AC square. Then prove that it is a right triangle. Okay. So now we'll take this. AB square is equal to 2AC square. We'll take the given thing. So AB square is equal to 2AC square can be written as AC square plus AC square. So AB square is equal to, instead of this AC, we will substitute BC, because AC is equal to BC. That becomes BC square plus AC square. So if you apply this to this triangle, the square on the longest side of the triangle, that is AB square, is equal to BC square plus AC square. That is, the square on one side of a triangle is equal to sum of the squares on the other two sides. Then those two sides contain the right angle. That is the converse of Pythagoras theorem. So therefore BC and AC should contain the right angle. BC and AC should contain the right angle. So therefore angle C is equal to 90 degrees. So if angle C becomes 90 degrees, therefore triangle ABC is a right angled triangle. Right. So this is according to converse of Pythagoras theorem. Right. So very simple, but you have to apply the converse very effectively. Right. Okay, let us get into the next problem. ABC is an equilateral triangle of side 2A units. ABC is an equilateral triangle of side 2A units. I hope yesterday we had solved a very similar problem on this. Find its altitude. Find its altitude. I will extend the question. Altitude and area. Okay. So this is an equilateral triangle. This is an equilateral triangle. Let us take it as triangle ABC and let us draw AD perpendicular to BC. Right. So ABC is an equilateral triangle of side 2A units. So this side is 2A units, this side is 2A units, and this side is also 2A units. So in the last session when we solved this problem, it was taken as A units. So here they are given it as 2A units. So problem becomes still more simple. So here, as AD is perpendicular to BC, it divides the base BC into two equal parts. So BC is 2A, so therefore as D is the midpoint of BC, BD will be A units and DC will be A units. Very simple. So in triangle ABC, AB is equal to BC is equal to AC is equal to 2A units, and AD perpendicular to BC. AD is perpendicular to BC. So therefore BD is equal to half of BC, half into BC. That is BD is equal to half into 2A. That is entire BC is 2A units. So 2 and 2 cancels. So BD is A units. So in triangle ABD, which is a right angle triangle, we will apply Pythagoras theorem to this. So we know the two sides and we can easily find out the third side. I hope you will do it as a homework. Right? So in triangle ABD, select this. Angle D is equal to 90 degrees. Apply Pythagoras theorem, that is AB square is equal to AD square plus BD square. Make AD square as the subject. Take squaring on both sides. You will get the value of AD, which is the altitude of the triangle. Then in the same manner continue with the area, that is half into base into height. So half into BC into AD. Put the value what you have just found out in AD, half into base into height, multiply that, take wherever perfect square is there, take it out of the square root and keep the answer in the most simplest form. So find out the altitude and area. So please send this to me through WhatsApp. Right. Right, we'll go with the sixth problem. Do that sum of the squares of sides of a rhombus squares of the sides of a rhombus is equal to the sum of squares on its diagonals. Right, so it's a very simple problem. Right. Before entering into the problem, let us try to understand this. Basically, what is being given and what is being asked. So prove that sum of the squares of sides of a rhombus. So we have to take a rhombus here. So I will take a rhombus. So we know that in a rhombus all the four sides are equal. So don't forget that basic concept. So here ABCD is a rhombus. So in the rhombus all the four sides are equal, opposite angles are equal, and diagonals are not equal actually. So this is the longer diagonal, this is the shorter diagonal, but they they bisect each other perpendicularly exactly, just like in a square. So in your 9th standard class you have studied the properties of rhombus. So prove that sum of the squares of sides of a rhombus. So I am going to build a square on the side of a rhombus. This is the square on this side of the rhombus. This is the square on this side of the rhombus. this is the square on this side of the rhombus, and this is the square on this side of the rhombus. So these are the 4 squares, 1, 2, 3 and 4. These are the 4 squares which are built on the sides of the rhombus. So here all the areas will be equal because the sides of the rhombus are equal. Therefore the area of the squares built on the sides of the rhombus are also equal, right? Sum of the squares of the sides of a rhombus. So this square area will be AD square. Okay, we'll start from here. This will be AB into AB is AB square. This is AB square. This will be BC square. That is BC into BC, you get this area. DC into DC, you will get this area, that is DC square. And AD into AD, that is AD square. So if you take the sum of the squares of all these 4, he is telling us, so therefore we will take it. So AB square plus BC square plus CD square plus AD square. The sum of the squares on the sides of the rhombus is equal to, we have to prove that it is equal to sum of the squares on its diagonals. Okay, now we will draw the diagonal. So this is the one of the diagonal and this is another diagonal. So squares are built on the diagonals. So I am going to build a square on this diagonal. This is the square which is built on this diagonal, and this is the square which is built on this diagonal. Right, so this is how the figure looks like. So here the sum of the squares on the sides of the rhombus, that is what I have written mathematically there, it is equal to the square which is built on one of the diagonal and the square which is built on another diagonal. So the problem means the sum of the squares which are built on the sides of the rhombus is equal to the sum of the areas of the squares, that is this area plus this area of the square which is built on both the diagonals. That is this area plus this area, this one plus this area plus this area is equal to this area plus this area which is built on diagonals. So that is AC square plus BD square. AC square plus BD square. So this is what we have to prove. Simply just looking at the problem, just practicing the problem what is taught by your teacher, presenting the same thing in the examination, getting marks, thinking that I am good in maths, all those things are not good. Actually this is the way you have to enter into a problem, right? So we will go with the solution for this. So we will go with the diagram. So let us take a rhombus. So let us take ABCD as the rhombus here. So AC and BD are the diagonals. So is the rhombus, ABCD is the rhombus. Okay, alright. So we will write that data. So ABCD is a rhombus. ABCD is a rhombus. Very important properties. AB is equal to BC is equal to CD is equal to AD. AB is equal to BC is equal to CD is equal to AD. All the 4 sides are equal. And AC perpendicular to BD. AC perpendicular to BD. So it's a property of the diagonals of a rhombus because they intersect or bisect, they intersect each other perpendicularly at point O. Okay. So diagonals intersect at point O. Okay. Right. So we have to prove that. To prove that AB square plus BC square plus CD square plus AD square is equal to AC square plus BD square. Just now we have proved that, that is, I showed you here. So AB square plus BC square plus CD square plus AD square is equal to AC square plus BD square. So this is what we have to prove. So no need of any construction. Let us get into the proof. Right. So here inside the rhombus we have 4 right angle triangles. Very important property, you have to remember this. Inside the rhombus we have 4 right angle triangles. In triangle AOB, angle O is equal to 90 degrees. We will apply Pythagoras theorem to this. So by applying Pythagoras theorem, AB square is equal to OA square plus OB square. OA square plus OB square. Right? So this is according to Pythagoras theorem. So AB square is equal to, here the diagonals they intersect each other perpendicularly as well as they bisect each other. So that's a very important property here. So OA bisects BD and BD bisects OA. So therefore OA is half of AC and OB is half of BD. So instead of OA I am going to write half of AC whole square plus, instead of OB I am going to write half of BD whole square. So half of BD whole square. So this can be written as AB square is equal to, the square applies for all the 3 elements, so that becomes AC square by 4 plus half BD whole square becomes BD square by 4. Okay, we will take LCM for this. So AB square is equal to, for AC square by 4 and BD square by 4, LCM is 4. So that becomes AC square plus BD square. So let us go with cross multiplication, and below AB square we have 1 as the denominator. So 4 into AB square is 4 AB square is equal to AC square plus BD square. So here 4 AB square we have to target here, because AB is equal to BC is equal to CD is equal to AD. So therefore this 4 AB square can be written as AB square plus AB square plus AB square plus AB square is equal to AC square plus BD square. So this can be written like this, because 1AB square, 1AB square, 1AB square, 1AB square is 4AB square. So 1AB square, we will write it in the same manner. So instead of AB, this AB is equal to BC. So therefore AB, instead of AB I am going to write BC square plus this AB is equal to CD. So instead of this AB I am going to write CD square, and AB is equal to AD. So instead of this AB I am going to write AD square is equal to AC square plus BD square. I hope this is what is to be proved. So this is how it goes. It's a 2 marks very important question, which was once asked in the Karnataka state syllabus final examinations for 2 marks. So this is a very important one. So please practice this, right? So with this problem I am going to conclude today's session, which was very important regarding the problems what we have done. So we have 2 riders in this session. Both are very important, including simple numericals. So please practice the problems, be updated, get ready for a test on coming Sunday on right angle triangles. The entire concept will be completed within this Sunday. So we are sending that is the homeworks and the worksheets through WhatsApp. I am very happy to see that good work is being done by you. You are going to get the fruits, you are going to eat the fruits of your hard work what you are doing now, because once the school opens, you do not know what are the things are going to happen. So please be updated. Let the schools open or not, that is a different criteria. Don't sit idle, learn something new, something good in your life at this particular time. Don't be idle, right? So stay home, stay safe and keep learning. Thank you.